The abstract for this written report is this analysis examine hazard and risk to workers in the paint manufacturing industry as well as environmental impacts. Major chemical hazards include solvents like benzene, metals, VOCs, and other toxic substances that can cause acute and chronic health effects including cancer, organ damage, and respiratory illness. Physical hazards like machinery, noise, and confined spaces also present risk of injury. Key environmental concerns of the paint industry include air pollution from VOC emissions, wastewater discharges, and improper hazardous waste disposal. Recommended hazard control focus on substitution of safer alternatives, engineering controls like automation and ventilation, administrative procedure, protective equipment, and ongoing exposure monitoring. While risk can be minimized with proper precaution, vigilant safety practices are vital to protect paint industry workers and the environment. This review aimed to advance understanding of paint industry risk and best practices for mitigation based on the hierarchy of hazard control. Further research and prevention efforts are needed in this essential but potentially hazardous sector.
Introduction. The paint production sector heavily uses benzene as a solvent agent, binding agents, and coloring agents to create high-quality products. However, this can lead to health issues for employees. Benzene can enter the air during manufacturing, posing risks to the nervous system, kidneys, liver, and reproductive health. Uncontrolled emissions can accumulate high concentrations of organic solvents in work area, endangering workers' health and safety. The research aims to determine the safe concentration of benzene for workers in the paint manufacturing industry in Sidoarjo, East Java, Indonesia. Solvents released into the atmosphere can raise tropospheric ozone levels, causing health risks. The threshold limit value for benzene compounds in the workplace is 0.5 parts per million, which is considered a human carcinogen. As for the issue, lead has been a component of mass-market consumer goods like lead-based paint for almost a century due to its protective qualities. Lead chromate and lead carbonate are used as white and yellow color pigments, while lead carbonate helps neutralize acidic breakdown products from paint oils. However, scientific studies have shown detrimental health effects and socio-economic costs of lead-based paint. In many underdeveloped nations, lead-based paint are still widely produced and used despite voluntary standards and mandatory limits. Industrial paints, such as anti-corrosive paints, are often uncontrolled, potentially posing hazards to the environment and human health. Paint production and consumption in developing countries lack legally binding control, with average lead concentration often in the range of tens of thousands of milligrams per kilogram. The problem is, the Global Alliance to Eliminate Lead Paint (GAELP) aims to eradicate lead in paint globally by 2020. Despite international efforts, hurdles remain, and political will among developed nations may lead to disappointment. A thorough review of the scientific literature on lead-based paint is crucial to address potential hazards to human health and the environment. The review includes insights into the manufacture, trade, and use of paints worldwide, the efficiency of regulatory controls in Asia, Latin America, and Europe, exposure sources and pathways, health risk management strategies, and environmental effects of lead-based paint.
Our objective of this study, first one, is to identify hazards and evaluate risks to the health of the workers in paint industry. Second is to evaluate the environmental effects towards accidental or purposeful exposures of the paint industry towards the flora and fauna. And third is to assign each hazards for identifying required corrective actions through the hierarchy of control to minimize the risks or eliminate the hazards. Significance of study. This study aims to build knowledge about the paint industry basics and facilitate long-term learning. It uses multiple studies backed by previous research and citations for proof of ideas. Research is crucial for improving knowledge and facilitating learning among readers.
Paint manufacturing employs approximately 200,000 workers worldwide, exposed to hazardous conditions at various stages of production. Workers are exposed to chemical compounds used in paint products, including pigments, extenders, binders, solvents, and additives. The painting is considered carcinogenic by the International Agency for Research in Cancer (IARC). But there is insufficient evidence for the carcinogenicity of occupational exposure in paint manufacturing. Main raw material for coating production are solvents, resins, pigment, and additives. Main solvents include cyanide, naphtha, formaldehyde, butyl acetate, ethyl acetate, butanol, ethanol, propanol, methylbutyl ketone, toluene, and ethyl cellulose. Resins include explosive resins, polyester resins, alkyd resins, polyamine, and other acylic polymeric resins. Metal oxide like zinc oxide, titanium dioxide, iron oxide, cuprous and cupric oxide are used as pigments. Additive enhance property of the paint like corrosion resistance, heat resistance. The use of lead has been phased out, but other proven carcinogens like carbon black, chromium, and silica.
For the hazard, we found two hazard in this written report. For the first one is chemical hazard in paint industry. Solvent enter the respiratory system through inhalation, inadvertent ingestion, or dermal absorption. Exposure to solvents can affect the auditory, central nervous, hepatic, renal, and respiratory system. Common occupational scenarios include material slip or fall or collapse, chemical burn or fire, chemical skin contact with paint or thinner, and physical repeated working behavior. For the health effect from the chemical hazard is acute effect. It causes immediate effects such as shortness of breath, difficulty breathing, and chest tightness, hypersensitivity, pneumonitis, and allergic reactions. As for the second one is irritation of the respiratory tract. Inhalation of certain paint chemicals, solvents, or volatile organic compounds, VOC, can cause irritation to the throat, respiratory passages, and nose. As for the chronic effect, long-term exposure to certain paint-related chemicals may contribute to chronic respiratory conditions, such as lung cancer risk. Prolonged exposure to carcinogenic substances in paints may increase the risk of developing lung cancer. For the physical hazard in the paint industry, for the first one is dust. Fine airborne dust from powdered ingredients can be inhaled, ingested, or combustible. Ventilation controls and respirators can reduce exposure, and dust explosion prevention is very crucial. For machinery, mixers, grinders, conveyor belts pose risk of getting caught or entangled, leading to injuries. Machine safeguarding and lockout procedures are very essential too. For the slip, trips, and fall, wet floors, slippery ingredients, cluttered workspaces, poor lighting can lead to slip, trips, and falls. And the good housekeeping is the key. Manual handling heavy bags of ingredients, drums of paint, moving prepared paint cans and pallets creates risk of sprains, strains, and musculoskeletal injuries. For the noise, exposure to loud noises from heavy machinery can lead to noise-induced hearing loss. Proper hearing protection is necessary. For the confined space, permit-required tanks, vessels, large mixers can expose to toxic fumes. For the chemical burns, hot ingredients, steam, or processes involving corrosive chemicals can lead to burns.
There are 8 environmental impacts of paint industry. The first is VOC emissions from paints and organic solvents contributing to the formation of photochemical ozone. Next is acceptable paints including latex, acrylic, and recycled latex paints unless they contain mercury or lead. VOCs are the most common toxic component of paint, with oil-based paints generally containing more than water-based paint. VOCs can cause health problems like nausea, dizziness, eye and respiratory irritation, heart, lung or kidney damage, and cancer. Fungicides and biocides in paints are hazardous and can be detected in the air 5 years after application. Pigments in paints provide color and opacity, but their manufacture can have significant environmental impacts. Colored pigments made from substances used to color them have minimal environmental impacts. Silica mineral pigments are generally low toxic and have minimal environmental impact. And lastly, solvents made from water or organic materials have minimal environmental impact. Every problem has to come a solution, so we use the hierarchy of control. The first is the personal awareness and communication are the key of safety. Next, safety management includes providing personal protection equipment, holding safety meetings and providing safety training. The next one is government should play a more active role in enforcing the law and setting up safety training initiatives. The hierarchy of risk includes elimination, substitution, engineering control, administrative control, and personal protective equipment. Elimination is the most effective control approach, while substitution is used if eradication is not feasible. Workers need to be trained and equipped with PPE to effectively handle dangers. This is the hierarchy of control. As you can see, the lower it goes, the less effective it is. And we start by elimination, which is to completely remove the hazard. And the next one is substitution, which is to replace the hazard instead. The third one is to engineering control, which is to isolate the people from the problem. The fourth one is to administrative control, which is to change how people work. And lastly, which is PPE, personal protective equipment, which is the workers themselves have to protect themselves with their equipment.
For our methodology, a literature search was conducted using various databases to identify articles on the environmental effect of the paint industry, and occupational hazard among workers in the paint industry. The results were categorized into chemical, physical, and ergonomic hazard. The hazard of the stacking or storing material at site can occur slip or fall or collapse of material due to poor material management. The second work activity is dilute paint with chemical thinner. The hazard can occur chemical skin contacts with paints and thinners, and chemical inhalation. The third work activity is painting. The hazard is chemical skin contacts with paint and thinner. It can occur the serious injury long-term can impair worker, skin dermatitis. Also, serious injury long-term can affect human.
The chemical-based paint industry is subject to various administrative controls and regulations, including EPA regulations for hazardous waste disposal, OSHA rules for worker safety, Clean Air Act guidelines, NPDES permit, SPCC plans, hazard communication standards, and prohibit on certain hazardous chemicals. Workers in the industry use critical personal protective equipment, PPE, such as respirators, eye protection, gloves, coveralls, head or foot protections, and hearing protections. Proper selections, training, and fit testing are crucial for PPE effectiveness. Monitoring agencies like EPA work with paint manufacturers to ensure compliance and legalization in case of violation. The company has implemented a policy for reducing physical hazards, including the elimination for certain chemicals and automation of process. However, local exhaust ventilation is not always optimal, and the hood position is inappropriate. Administrative control include medical checkup for employees, provision of changing room, local facility, and a hazardous communication system. Personal protective equipment is also provided, including head, eye, ear, body, hand, respiratory, and leg protection, which is heavily relied upon for worker protection.
Continue. For the conclusion, the paint chemical industry faces occupational health and safety challenges due to toxic ingredients. To reduce risk through identification, engineering control, proper work practices, protective equipment, and monitoring exposures are essential. However, eliminating residual risk requires continuous vigilance and a commitment to safety. Key recommendation for this industry is include substitution of hazard, ventilation, training, safety culture, and ongoing hazard analysis. As for the recommendation, we found 11 recommendations for the paint industry hazard analysis. For the first one is substitute hazardous ingredients with less toxic alternatives, enclose high hazard processes like paint mixings and grinding, establish and enforce exposure limits for hazardous chemicals. For the fourth one is provide proper respiratory, skin, and eye protection matched to chemical hazard. For the fifth one is reduce potential fire and explosion risk through chemical substitution, bonding, grounding, avoiding ignition sources, and controlling dust. For the sixth one, conduct comprehensive training programs covering hazards control, safe work practices, emergency response, PPE, and etc. For the 7th one, conduct regular safety inspection and audits to identify improvement opportunities. For the 8th one, involve joint health and safety committees. For the 9th one, implement medical surveillance programs for early detection of chronic illnesses from chemical exposure. For the 10th one, encourage reporting of near misses and safety incidents without reprisal. For the last one is remain vigilant to emerging hazards as ingredients and operation change.